This video covers section 4.4, which discusses parallel and perpendicular lines. Now, we discussed these in the 4.3 lessons, but we're going to go into a little bit more detail in this lesson. We'll start off by discussing perpendicular lines. Now, I'm sure you've heard this term before, and typically we refer to this when we have two lines that intersect at a 90-degree angle. Well, that would be a geometric interpretation of it, and we're going to talk about the algebraic interpretation of it, which is that either one line is vertical and the other is horizontal, similar to the x and y axes. And in that case, one of those lines, the horizontal line, has a slope of 0, and the vertical line has an undefined slope. Or neither is vertical, and the slope of one line is the negative reciprocal of the other. In other words, if you have one slope, if you flip it over to get the reciprocal and then switch the sign on it, you would get the slope of the perpendicular line. So that is how we define a perpendicular line. Parallel lines are a little bit easier to define. Either they are both perpendicular to the x-axis, meaning the slope is undefined, you have two vertical lines, or they have the same slope and a different y-intercept. And it's very important that they have a different y-intercept, otherwise they are the same line. So in this case, they have the same slope because they are rising and running at the same rate, and therefore will never intersect. So, a few examples. If we want to find the equation of the line that has a y-intercept of 8 and is parallel to the line y equals negative 2, then, well, we know that y equals negative 2 is a horizontal line, and if we want something that is parallel to this, we want another horizontal line, meaning that it is going to have a similar form, y equals. So in this case, though, we are intersecting at 8, so we get the line y equals 8. In example 18, we want to find the equation of the line that has a y-intercept of 14 and is perpendicular to the line x equals 10. So x equals 10 we know is a vertical line. If we want to find something that is perpendicular to it, then we would want to find a horizontal line, and we want to find a horizontal line that is going to take the form y equals, and we have a y-intercept of 14, so that is our equation. Now, if we want to deal with lines that are not horizontal or vertical, again, we need to follow those other definitions. And these first examples, we just want to determine whether or not the given equations are parallel, perpendicular, or neither, because they can cross at other angles than 90 degrees. What we want to do in this case is we're going to look at this first equation. We're going to put it in slope-intercept form because essentially what we're interested in is the slope. So I'm going to subtract that x over, and I'm going to add the 7 to both sides, and we're going to have 3y is equal to negative x plus 7. Last step, we divide by 3. So we end up with y is equal to negative 1/3 x plus 7/3. So in this case, we'll call this m1 is negative 1/3. That is our slope, that is the number in front of x. Likewise, if we come over here and we look at the second equation, I'm going to add our 3x and subtract 2 from both sides. And we are then left with y is equal to 3x minus 2. So this one's already in slope-intercept form. And in this case, m2, our second slope, is 3. Now we want to compare these two numbers, m1 and m2. First of all, are they reciprocals? Yes. 3 and 1/3 are reciprocals. And we want to see if they have opposite signs. 3 is positive, negative 1/3 is negative, so in this case it is a negative reciprocal, and therefore we have perpendicular lines. And a shorthand for this is just something that kind of looks like an upside-down T, where those two lines are perpendicular. I want you to pause the video at this point and try example 20, and then resume the video to see if you've got the correct answer. So in this case, if you went through and solved the first equation in terms of slope-intercept form, you should have found that y was equal to 1/3 x minus 22/9, and our slope here would be 1/3. If you solve the other equation, you end up with y is equal to negative 1/3 x plus 17/3, and so therefore our slope is negative 1/3. If you compare negative 1/3 and 1/3, yes, they are opposite signs, but they are not reciprocals. So in this case, we end up with neither, because they're not equal and they're not negative reciprocals. So we end up with neither. If both of them had been positive or negative, then we would have had parallel lines. But in this case, since one is negative and one is positive, we have neither parallel nor perpendicular. Working the other way, if we want to actually find a line based on a given slope, or to find that if it's perpendicular or parallel to a line, we go back to the information we learned in 4.3 about how to find an equation based on the point-slope form. So in this case, we want to find an equation of the line that passes through a given point, negative 7, 4, and is perpendicular to the line 5y equals x. So in this case, the first thing we need to do is we need to solve that line to find our slope. So essentially we need to divide both sides by 5, so y is equal to 1/5 x. In this case, our m1 is 1/5. Now if we want to find the line that is perpendicular to this, we are going to need to flip this over, so we're going to need to find a second slope. Flip that over to get the reciprocal as 5, change the sign, we get negative 5. And this is the step that a lot of students forget about. We need to make sure that when it's perpendicular, we take the negative reciprocal of the first slope. So this is our first step. Second step is we're going to use the point slope form. So we're going to say y minus our y1 was 4 equals our slope is negative 5, and then we have x minus our x value here, which is negative 7. And now we need to simplify and put things in slope-intercept form. So we have y minus 4 is equal to negative 5 times x plus 7. If we distribute that negative 5, we get y minus 4 is equal to negative 5x minus 35. And if we add that 4 to the other side, we end up with a final answer of y is equal to negative 5x minus 31. And this is our final answer. This is the equation of the line that is perpendicular to the original line 5y equals x. I want you to pause the video now and try this next example. Notice that in this case we're keeping things parallel, so our slopes are going to be equal, and it's passing through the origin, which can be thought of as the point 0, 0. So take a second, work through this problem, and then resume the video to see if you have the correct answer. So in this case, you should have found that your slope was negative 4/5, and since this is parallel, we keep that slope. We don't change anything. And then all we have to do is plug in our point 0, 0, which happens to be our y-intercept, and we end up with a line, an equation of a line, which is y equals negative 4/5 x. We have one final example here, a bit of an application, and we wanted to determine, given these points here, which are the corners of a quadrilateral, we want to first determine if it's a parallelogram, and then if it's a rectangle. So take a second to think about what would cause this to be a parallelogram, what it means for a quadrilateral or a four-sided shape to be a parallelogram. Well, the definition of a parallelogram is that opposite sides are parallel. So if we wanted to determine that, we can graph the points if we want to, but we don't have to. It might be helpful just to see where everything is located. I'm going to make each increment 2 because we have that 9 and 6 there, and the 5 and 7. So in this case, we have the point negative 2 and then 3. That's A. B is at 2, 2. C is at 9, 6. And D is at 5, 7. So if we wanted to connect these, and again, this isn't the best drawing, it looks kind of like it's a parallelogram, but we want to be certain. We can't always trust the pictures. So in this case, we want to find out if AB, the line AB, is parallel to line DC. So we will find the slope of AB, and in this case we're comparing A and B. So we would have 2 minus 3 over 2 minus negative 2. So this comes out to be negative 1/4. And then we want to find the slope of DC. And in this case, D is at 5, 7, C is at 9, 6. So we've got 7 minus 6 over 5 minus 9. And again, we come up with, in this case, 1 over negative 4, which is still negative 1/4. So since MAB equals MDC, we know that AB line segment is parallel, so this is the shorthand for parallel, to line segment DC. Now I want you to pause the video and find out if the line AD is parallel to the line BC. So you should have found that both of these slopes equal 4/7, and so AD is parallel to BC. So since we've done all of this, we know that this is a quadrilateral. We have to answer the original question, which is yes, it is a quadrilateral because of the following information. Now, if we want to determine if it's a rectangle, again, remember that a rectangle says that not only is it a parallelogram, meaning the top and bottom are parallel and both sides are parallel to each other, but that these are also at a 90-degree angle. Now, looking at the picture, this does not look like a rectangle, but we can justify this using the information that we've already calculated. If it were to be a quadrilateral, we would need, for instance, line segment AD to be perpendicular to AB. And if you compare the slopes here, MAD we found to be 4/7, and MAB we found to be negative 1/4. These are not negative reciprocals. So is not the negative reciprocal of MAB, which is negative 1/4. So AB or AD is not perpendicular to line AB, and this is not a rectangle. So that is an algebraic way, an analytic geometry way of figuring out whether or not a given quadrilateral is either a parallelogram or a rectangle. So this concludes the video for 4.4. Please go online and complete the homework for this section, and then watch the video for 4.5.